So here we are looking at my DIY tracker. I decided to make actually about 15 years ago, believe it or not, and it's taken me all this time to actually get my act together. Anyhow, I want to say right out from the beginning that it is actually much cheaper just to buy extra panels and install them instead of building a tracker like this. Not to mention it'll save you pulling out all your hair. Anyhow, the problem that we have here is that we can't have a big showy display of panels because we're in a nature reserve area and everything's supposed to be natural, right? So of course a big, 7-panel array is just not really natural. So I decided a long time ago, like I said, that I was going to build this, and finally came to fruition. Not exactly as I had envisioned it, but it is working, and it does the job when the sun is actually out. This time of year the sun's not out very much, so we're looking forward to March. Right now we're in January. In March the sun starts coming out, and it's beautiful, warm, warmish for winter anyways, but also sunny, very sunny usually. Hey. Okay, here we are as Paul's monstrosity, and right now of course it's the winter time, so I'm out in the ice, but this tracker sits out in the lake slightly because I need to be able to clear the tree line. As you can see, the tree line gets to be in the way, especially over this way, so it's better if we just stick within the tree line. So just a little quick show of the gear setup here, the way how the thing works. Forgive me with the ugliness of the shields to protect the drive line, the chains and so on, the gearbox. And anyhow, so we've got our controller down here. They have the power switch on the left, and sorry, that's not a power switch on the left. This is the power switch on the right, and on the left we have the PV disconnect for the panels. So up here we've got a 12-inch linear actuator, and underneath, a little bit hard to see, underneath here we've got a Bodine motor drive. This is a 45 RPM 12 volt motor drive, only takes 5 amps to power. There we have, I'll show you some pictures a little bit later on, but right there we have the counter for the revolution counter to see how many times the drive's turned around. As you can see, I had to do a little bit of a funky setup here because it's a DIY stuff and trying to keep the price down. As you can see right there, it's a 60-to-1 reduction worm drive with a 1-inch output shaft. And anyways, we had to weld up all these gears and everything. The top, which you can't really see right now, hooks up to, this is a hub for a trailer, and the chain drive hooks up to the hub, and that's what turns the whole thing. So the whole thing secured to the post. So not the prettiest thing you've ever seen, but it does work. And for the second axis here, all we have is a couple of hinges that's sitting on here. Bloody nightmare. Okay, so one of the things that I forgot to mention was I've got this set up so everything works off of Bluetooth, and I don't know if that'll focus in or not. I've got a few commands set up at the bottom. This is a serial program from just downloaded from Google Play, and anyhow, I'm about to tell it to, just in manual mode right now, I'm just about to tell it to move to home, right? So, okay, there we go. It's just jogging slowly right now, right? It's gonna move to home. When it's in automatic, it actually moves quite a bit faster. Okay, And that's the sound of the elevation adjusting. Hard to see. It's bringing it down to 14. Okay, so I don't know if you'll be able to see that or not. Focus her right in. It shows that the PV azimuth is at 180 and the elevation is at 14 degrees. That's the home position right now. Okay, good stuff. Okay guys, I just wanted to quickly go over some of the design considerations before we move on to the internals of the electronics. So essentially I wanted to have the frontal view of the whole tracker and the PV array to be as minimal as possible, just for the consideration of the people across the lake and other neighbors. I wanted the panels to be able to tilt from 0 to just about 90 degrees to be able to cover all the angles of the sun that we're experience over the summer, particularly in the longest days of the year. So the base of the tracker was designed so that when it was all the way down to 0 degrees, the elevation, the tilt, was all the way down to 0 degrees, that it could still turn about the azimuth axis. Also note the concrete blocks here are used to keep the base of the tracker down, since it's essentially designed the same as a dock. It has little feet to go down to the bottom of the lake, which only, at this point, is only a couple of feet deep. But we do get some high winds here, and we need to make sure that this is adequately weighted down to make sure it just doesn't tip over and we lose the whole thing. So at this moment, the full travel is about 14 degrees up from the ground plane to about 74 degrees up from the ground plane. If I was to do this again, I would probably make this actuator about 18 inches or 16 inches, something like that, and move this bar up a couple of notches. It'll be a little bit easier on it and hopefully be able to get the full tilt that I was looking for. You guys may not have the same problems anyways and may not require that. I just had this kicking around from a few years ago. Like I said, I've been working on this for about 15 years now. Anyhow, another consideration are these cables here. Now, they look like a big bloody mess, and they will get cleaned up a little bit eventually, but they need to be able to hang free. And one of the problems is it's really tough finding control cables and that are flexible enough. And it's cold because it gets down to about minus 30 here sometimes Celsius. And the flexibility of the PVC that they use on the cables is just pretty much non-existent, which is a problem. So need silicone or some sort of rubber. This cable here is the main cable for the PV array is actually cab tire, which is a rubber coating on the wires. So moving on to the internals of the controller, just go over this briefly. This is Arduino Mega 2560. It has, obviously, as you can see, the terminal board on top of that, which helps greatly instead of trying to fiddle around with all the pins and crap like that. This cable here is a USB extension cable, and I have it mounted in the bottom of the cabinet here to just so I can plug in and off every time I want to program. I don't have to keep taking the cover off. So there's a view of the connector board, and everything's marked out pretty well. It's not perfect, but and these things aren't cheap either. About 45 bucks Canadian, I guess, whatever that is in the US, maybe 30 bucks. So right here, I have an SD card. Everything is recorded, all the data recorded for every move and every fault that happens, and whatever else I need to record to that gets recorded there. Over here is a real-time clock. And that's just used, as I said earlier, for the calculations to figure out where the sun is, what time of day. And down below, this right here is a four-channel relay board, which makes things so much easier. And essentially, it helps with also with this is the motor controller. Instead of buying two motor controller boards, I needed. I originally intended to have a brake system on the controller, but wasn't able to get that happening, and the worm gear drive is seems to be adequate enough for stopping it from the wind blowing it around. So the this board here, the motor controller board, only one axis moves at once, and it's just fed in through here. So one relay will come on, motor controller will move that axis, and then we'll switch over to the next axis, and the same motor controller moves that axis. Just a couple other notes about the internals here. This is a power feed. It's 12 volts from the battery bank up the hill. It's also meant to be make available for a voltage reference, so I can tell at some point whether the panels are fully charged, and we don't need to run the tracker. But at this point, it's just it just goes straight through. We up in central Ontario here need to be reasonably assured that this stuff is going to work at cold temperatures, probably down to -30, -35 Celsius. But at any rate, the coldest that this system has run so far has been -24 degrees Celsius, and it seemed to handle it without any problem, with the exception of the drivetrain gear. Doesn't like the cold that much, but I was able to make some adjustments, and yeah, everything seems to be working great. There's more to come in the next few videos that will detail the construction of the drivetrain, the importance of some of its features, and also the schematics for the electrical connections here, and eventually the code that we'll go over that runs the whole thing. Thanks for joining me. We'll see you soon.